Today on This Week in Space, we look at the rise of the Megarockets.
Podcasts you love.
From people you trust.
This is TWiT.
This is This Week in Space, episode number 37, recorded November 11th, 2022, Rise of the Megarockets. This episode of This Week in Space is brought to you by Melissa. Over 10,000 clients worldwide in industries like retail, education, healthcare, insurance, finance, and government rely on Melissa for full spectrum data quality and ID verification software. Make sure your customer contact data is up to date. Get started today with 1,000 records clean for free at melissa.com/twit. Hello and welcome to another episode of This Week in Space, the Rise of the Megarockets edition. I'm Rod Pyle, editor-in-chief of Ad Astra magazine, of course, and I'm joined by the unstoppable Tariq Malik, editor-in-chief at space.com. Notice I went from I words to you words for you, Tariq. It's time for a shake-up.
I love it, and I appreciate it. And you, Rod, as always. So thank you very much, and very happy to talk about rockets. It's kind of like, that's my jam at space.com, is the rockets. So I'm very excited about today.
And that's why for Christmas, I'm sending you a hat with a big L on the top. Well, that's good to hear. And, you know, I just wanted to say, because you get all the cool press junkets because you're with space.com, I spent the week at two workshops. I was at the Moon Village Association's annual meeting for 2 days, which was very cool. Talked a lot about lunar settlements and in situ resource utilization for building moon settlements and how we'll get there and what we'll do there and all that stuff. And then yesterday and today is the National Space Society Space Settlement Summit, which was fun and engaging and will continue to be today. And that's looking out anywhere from 5 to 30 years at how we'll get people moved off this planet and off to other ones. And always gives me a kickstart for a new year. And if our listeners are interested in these kind of events, there are always news updates at the NSS.org website, National Space Society's website, and in the Society's biweekly newsletter, if you join, which is available to members. And parts of these conferences are also streamed out online and archived for later viewing. And if you're interested in any of these, drop us a line. I'll be sure to mention them on the podcast. And they also pop up on space.com from time to time.
Yeah.
And since you won't give me your chair, I also want to point out that I'm going to a fundraiser tonight for the same organization. I get to hang out with John Delancey over dinner.
Wow. Q himself.
You
should tell him. You should ask him to fix my Star Trek chair, because I'm sure that's within.
He can just blink and nod his head, right? Be like Bewitched.
If anyone is interested in what the Star Trek chair looks like, they should check out my Twitter, which you can get at the end of the show, because someone did ask about it, and I did tweet out a picture of the setup.
Really?
You can see the chair. Yeah.
It's not that awesome. I just like to give you grief about something. And your car sounds so pathetic. I can't lean on that. We also have members of the cast and crew of the Orville coming, and some other impossibly cool people.
That sounds really awesome.
So that'll be fun. Yeah. It should be really, really neat. And it's a fundraiser for STEM education. So all for a good cause out in Los Angeles at the Sheraton Gateway LAX. So before we embark on our discussion of SLS and Starship, which is our topic today, I have a joke.
Okay, I'm ready.
Sort of.
I'm ready. Should we do a countdown? Like 3, 2, 1. Let's go.
This will be an SLS countdown because this one probably won't get off the pad either. This is from Logan Jaron, I think his name is pronounced, of Space Hipsters on Facebook. And I'm getting these from Space Hipsters because our audience isn't sending me quite as many as I'd like. And I'm shocked because there's so many bad jokes out there. So Neil Armstrong is said to have once commented that jokes told on the moon that fail to get a laugh are regarded that way by comedians that don't understand the gravity of their situation. Yeah, kind of a built-in punchline. I'm not sure I actually understand that one, but
I had to think about it a bit.
Where's the ending? Oh, I get it.
I got about 1/6 of that joke, Rod. If that makes sense.
Oh, good. That was good. 16%. Oh, you get a rim shot. That's a first. As a reminder, audience, we're soliciting your best space jokes. Well, any space jokes, but good ones would be nice. Give us your best shot at twit.tv. That's TWIS at twit.tv. where you're already sending your fan mail in droves. Thank you for that. Each week, we'll pick one or two of the best ones and read them on the air with credit to you, because you are the most important people to us. No fortune, just fame. All right, let's move on to headlines because we got some cool headlines this week. Hey, I've got an idea. How about an Artemis 1 update?
Oh, the joy, Rod. Oh, the joy. So
It sounds more like Dr. Smith on Lost in Space. The pain, Will, the pain.
When we last left our friend, the Artemis 1 SLS moon rocket, it had just returned to the pad and was gearing up for what was supposed to be a launch on November the 16th, 2022. Since then, Tropical Storm Nicole has washed over the Florida Space Coast, and in a stunning turn, NASA left the rocket out on the launch pad. Now, they made this decision early last week, so we they had said that they didn't think that there was going to be any issue. The SLS rocket is rated to stand about 74 knots of speed from storms, and they had said that their forecasts were well below that, in like the 40s. And this is from Ars Technica, by the way, by Eric Berger, who is a meteorologist by training before he became a space reporter. The guy knows his stuff.
I didn't know that. That's interesting.
Yeah, he used to run their weather site at the Houston Chronicle before moving to Ars. And everyone should check this out, because it's mind-boggling to think that you would leave a $4 billion rocket on the launch pad during a tropical storm. But we've seen, risk assessments in the past where, hey, the storm's not going to be that high. The rocket can take the winds. That's great. On Thursday of this week, so the day before we're recording this, the rocket was hit with 100-mile-an-hour winds. That's basically hurricane strength winds. These gusts for hours over time, not the entire time, but for hours. So it was subjected to winds that could have exceeded its tolerance that it's supposed to. Now, Jim Free of NASA did say that their sensor at a certain level, a 60-foot level, never exceeded the wind speed that it's designed for, that's 74 knots. But there is damage, minor damage is what they're saying, at the launch pad, possibly the rocket itself. There are engineers, as we are talking, looking at it and seeing what can they do to fix it, or if they can fix it, or how bad it is. We're not sure what minor is. It's been very difficult to get clear information because it's a developing situation. And NASA will be announcing this, so you may, listeners, hear it before this audio or this podcast goes out. They're going to have a press conference that's going to say, this is what it is. This is what the damage is. Maybe we can make the 16th. Maybe they'll say they're going to keep checking. It's very difficult to plan for that, but that's what's happened right now. It's they kind of tossed the dice that the storm wasn't going to be bad. It may have been worse than they were expecting, and there's damage at the pad. We'll see how bad it is and if they can fix it. But according to Eric Berger at Ars Technica and a lot of space reporters that I've been talking to, there's a lot of questions about, first of all, if it was really the best decision to leave the rocket on the pad. And then also, if they can not only make the 16th, but if they can make this window entirely. Now, you might recall they skipped the November 14th launch date. It is now the 16th. And they have one more day, the 19th, in this window before they have to decide, do they want to try during, Thanksgiving weekend or not, or go all the way to December. I'm just going to point out, Eric Berger back in 2020 did write a story saying that they could fly in 2023. He might be right after all. And that's the update for today.
Well, 2023 has been my guess for a while, but I was born snarky. And I have to admit, on the snark side, when I saw this story, it for some reason made me think of the beginning of The Martian, where apparently the slightest breeze can blow over a rocket on Mars, even though it's got practically no atmosphere. So, when you talk about 100 miles an hour at sea level at 14 plus pounds per square inch, that's probably a lot of wind. And I wonder how much of the decision was the delay that the drive back to the VAB would cost, and how much of the decisions about, and I'm not an engineer, so I'm spitballing here, is about, the risks of driving back and forth, because it's a rattly ride. And every time you do that,
there's risks.
Yeah.
There was talk early on a few months ago that there's maybe that the stacked configuration of SLS the optimum number of maximum rollbacks or rollouts was 3. They've done that already.
Yeah.
So that adds extra stress on the entire vehicle. It's 322 feet tall. It's not small. The other fact that we haven't talked about too much is that the solid rocket boosters that have been stacked for the SLS have an expiration date. And right now,
Right.
that expiration date, they've been stacked for a long time. That expiration date is sometime in December, when after that, NASA and Northrop Grumman, who builds them for the SLS, will have to discuss if they can leave them stacked and still be confident that they'll work as planned, or if they got to take them apart, check them out and put them back together again. A lot of open questions here about what's going on, but hopefully we'll get some clarity over the weekend after you and I finish here, and if we're lucky, then next week when we talk, next episode, we'll talk all about a great and glowing launch that was successful.
Please.
Otherwise, we'll have to figure out what's happening.
Well, and since we're indulging ourselves in this headline, because we are talking about SLS today, did they replace the, hey, it's going off course, let's make it go kaboom flight termination batteries, or not?
Now, they said that they addressed all of those kind of issues that were clouding the rollback scenario back in September, when they decided to stand down, for the duration until this current window. So all of that stuff should be taken care of. Now, there are some things that they couldn't replace, some batteries on the CubeSats that are too hard to get to because they're stacked in that configuration. That kind of stuff, there isn't much to do. The NASA's response has been that the PIs and the folks that built those vehicles knew that there was limited access, knew and have either prepared for it, or will just do the best that they can. So, we haven't heard too much about like the lifetime for those, but hopefully they'll be fine. It really depends what's going to happen after this storm, what the impact is. It's hard for me to fathom that they'll be able to keep the 16th, but this is NASA. They really want to try to squeeze every possibility out of the time that they have, and we can expect that they'll do the same here.
All right. Next story on a more sobering note, and I heard this last night as I was driving home from the conference just before everybody's favorite show, Coast to Coast, came on AM radio. A remnant of the Challenger was found at the bottom of the Atlantic by a History Channel crew working on a show, and that comes to us from MSN.com. What did you hear about that?
Yeah, this was actually a surprise to me. I mean, this is a film crew that was out looking for the wreckage of a World War II plane, and as they were, working at the seafloor, they found this wreckage that they were surprised it wasn't what they were looking for, and they did confirm it with NASA that it is remains of the Space Shuttle Challenger in the Atlantic. The Space Shuttle broke apart when the Challenger explosion happened. It wasn't so much that the shuttle itself exploded. It was kind of a massive break apart event, and many pieces of debris have fallen, and NASA's collected a lot of them. They're locked away in a bunker, and so there's still some out there. Everything that they could find, NASA found a lot. Even the crew compartment, they did find that. And so this is just like another sobering reminder about the impact of mistakes that we're talking about SLS, right now, why they're being so careful, because they want to make sure that everything is right. And, there are consequences, and this is a reminder. And so, it's just kind of an interesting story that reminds you that there are things out there. They found a bunch of tiles that were still in the wreckage. They think it may be from the belly of the space shuttle itself.
It's a big chunk, right?
Yeah, I mean, and you can see in the images, and I recommend everyone go check it out. I mean, they've got a pretty big seas. It looks like it's the size of a table in my eye, because they have a tape measure that these divers are holding next to it in the image, and so hopefully they'll be able to recover that, and NASA will be able to study it and see like how it's fared, and maybe add that to the debris that they do have to understand better how the shuttle came apart and how they can make spacecraft safer.
And if you ever have a chance to visit Kennedy Space Center, I highly recommend going through the museum there. There is a display of a large piece of Challenger, which is very respectfully put up in a corner, sort of in a shadow box. And it's not unusual to see people standing there with tears streaming down their face, if you remember that in 1986 when it exploded. And to your point, there was a large fireball because the fuel's ignited when the solids, one of the solids came loose and I guess really rotated into the main fuel tank and released all those volatiles that came out and ignited. But my understanding is what actually destroyed the orbiter was aerodynamic stresses, because as everybody who's seen the shuttle knows, it was kind of an awkward configuration for something that's hurtling through the air at thousands of miles an hour, unlike something like Artemis or Starship, which is very streamlined. And the aerodynamic forces broke it up. And to that point, we could barely see it in the video from the day, which of course was vastly inferior to what you see today. But apparently the crew cabin came down more or less in one piece, with because the crew did live quite a number of minutes after the actual event. So it's just distressing all the way around. But it's good to find any bits of forensic evidence you can, because that all helps.
That's right. And to just to remind readers that, or listeners that may not recall, this was of course the STS a flight that had Krista McAuliffe, the teacher, the first teacher in space, the civilian, and a crew, of 7 altogether that were lost during that flight. It was the first of the 2 fatal accidents that NASA had. Now, this footage, by the way, was recorded during the taping of a show called The Bermuda Triangle into Cursed Waters.
Yes.
So I just want to point that out, because it is very likely that when these shows when the show airs, that you'll see a lot of this footage in there from that discovery that they made. So,
and I just pray that they don't try to make a link between the Bermuda Triangle and the accident, because that would be extremely
I would
disrespectful.
I think they'd be very respectful. Yeah.
Well, you've never worked for the History Channel, or maybe you have. I know I have. Finally, we have a beautiful piece of clickbait that you dropped me. Thank you for this. NASA tests a flying saucer. So this is an inflatable heat shield, which is something they've been working on for a long time. And the basic idea, if I may, is when you launch a rocket, your structure is usually, especially pieces of hardware like a heat shield, is usually restrained by or constrained by the diameter of the rocket fairing, which is generally around 15 feet, unless it's a much larger rocket. And that's not very big. And if you're going to Mars or some other places, you want as much drag as you can get on the way down. And Mars is particularly tricky because the atmosphere is so thin that on the one hand, it doesn't slow you down enough to be traveling as slowly as you'd like to before you get to the surface, which is why they also have to have retrofire rockets. But it is dense enough to do a lot of heating and cause a lot of dynamic complications going down. So it's kind of the worst of both worlds there. So having a much larger drag area like this is really good. They did try something a few years ago, they being JPL NASA, called the low density supersonic decelerator, which is similar to this. Didn't work out very well, but apparently this new design did.
Yeah. I'll point out that this is a story by my friend and colleague Elizabeth Howell over at space.com. We all watched.
Oh, we like Elizabeth.
Yeah, that's right. We all watched NASA and NOAA and the United Launch Alliance launch a really powerful Earth watching satellite, the JPSS-2, and part of that mission. So that satellite is in orbit now, doing its thing, looking at Earth, tracking the weather. But they carried this thing. It's called lofted low. I'm going to get this acronym wrong, I'm sure.
another acronym. Yeah.
Low Earth orbit flight test. Now, the idea is that if you're gonna land a big thing on Mars, and habitat that astronauts are going to live in, a large vehicle that you don't want to use all the fuel on because you need that fuel to take off. You need a different way to land these big things on Mars, or to bring big things back to Earth. And having a bigger heat shield that weighs a lot less is part of that. So they have this idea it's like a cone shaped inflatable balloon that is wrapped in many different layers of heat resistant material that they can use as like a really kind of a blunt shuttlecock type heat shield that'll let large payloads come back to Earth. And when they did test this before, it was suborbital for the most part. It was not from an actual orbital altitude. And that was really key to this test. So they launched it. It went into orbit with this satellite. The ULA's upper stage, the Centaur upper stage, released this decelerator. It survived reentry, 18,000 miles an hour plus, searing hot temperatures of 3,000 degrees Fahrenheit. It plunged through the Earth's atmosphere. It's about 20 feet wide, if you can imagine. So a very large, it would fit inside a room, if you would. And it not only made it all the way down, it splashed down about 5 miles from the recovery ship, 500 miles off the coast of Hawaii. I mean, they found it really fast, and it was fully intact. It was still inflated. It was all in one piece. It really just kind of performed across the board. And the engineers behind this were really excited because it proved that this concept is scalable and that they can really kind of widen their envelope for how big of a payload they want to bring back to Earth. And they can, bring stuff back from the moon if they need to. They can, land on Mars as long as they keep the physics of what the atmospheres are like. They can use this for whatever they would like. So.
Well, and just historically, a note: the Soviets did something not dissimilar to this on some of their Venus landers. And the great thing about a place like Venus or Titan, because they have dense atmospheres, is you can use a system like this and possibly get away without having parachutes or retro rockets, landing rockets. And it solves a whole bunch of problems. And again, is something that can scale up way beyond the fairing size of the rocket. Although with Starship going up soon, we hope you'll be able to have much bigger structures going into orbit and beyond. But, if you've got a 30-foot diameter Starship, you can put in a 90-foot diameter inflatable heat shield if you wish, as long as it tests out at scale, which is always a question mark.
I should point out, Rod, too, it was not just the heat shield alone that made it back to the ground. It did have a parachute on it. So after it got through the atmosphere, it deployed a parachute so that it could make a splashdown in the ocean. So it didn't just kind of like plunge all the way through and glide back down. It did have that more traditional type of thing. But, on Mars, you need to get through the heating and slow yourself down a lot because the as you mentioned, the air is super thin, and parachutes just don't perform like they do on Earth, where we have a thicker atmosphere.
Although on Venus and Titan, guys like you and me who are a little bigger than the average bear could probably go down without a parachute or a decelerator and just land on our feet and walk away because we'd have lots of drag.
If you don't mind the crushing pressure or the searing hot temperature, yeah. For sure.
Cry me a river. You East Coast guys are some bamby-pamby. All right. We will be back to talk about moon rockets after this short message, so don't go anywhere. This episode of This Week in Space is brought to you by Melissa. Melissa is a leading provider of global data quality and address management solutions. Poor data quality can cost organizations an average of $15 million each year. That's a lot of money. You shouldn't waste your marketing dollars. Be sure to manage your budgets effectively and smart, as the longer poor quality data stays in your system, the more losses you could accumulate. To ensure your business is successful, your customer information needs to be accurate, as high quality data will save you money. And there's another side to accurate data: email deliverability. Email providers often have additional authentication protocols designed as a response to the increase in spam and fraud within the email industry. However, these protocols mean there's a higher chance of undeliverable emails because of a misconfiguration on the sender side of things. Melissa's global email can identify which authentication systems are in place for the MX server of the email during validation, so you can make changes to your MX server settings and improve deliverability prior to actually sending the email. Melissa's global email identifies potential business impending authentication systems such as SPF, or Sender Policy Framework, DKIM, Domain Key Identified Mail, DMARC, Domain-Based Message Authentication Reporting and Conformance, and following best practices for DMARC, DKIM, and SPF, and utilizing email validation will result in maximizing your email deliverability and improving ROI on leads, reducing costly IP reputation damage and spammer designations, and increasing email security and adherence to industry standard protocols. Melissa's global email verification service removes up to 95% of bad email addresses, helping you increase deliverability, avoid high bounce rates and blacklisting, and protect your valuable sender reputation. And their solution verifies emails in real time, pinging each email to ensure it's active and able to receive email, and corrects typos and illegal characters, and detects mobile email addresses that shouldn't receive commercial email messages. In short, Melissa is experienced, independent, and has 37 years of data quality expertise. Make sure your customer contact data is up to date. Get started today with 1,000 records clean for free at melissa.com/twit. That's melissa.com/twit. All right. So before we begin, I just want to point out we have an excellent summary article comparing SLS to Starship head to head. If you go to the nss.org website and there's a button in the middle right that says, quote, click on free moon rockets article. Not very creative. It's an article by John Cross from my magazine Ad Astra, and it's a good, probably about 3,600 words. So it's a moderate read that really stacks these things up apples to apples, because one of the things that's going to come up in this discussion is that it's really hard to compare SLS to Starship and either of them to the Saturn V, which is kind of course, the gold standard for big rockets that go to the moon, because it's the only one we've had that could carry humans to the moon. Because they're configured differently, their stage configurations are different, the mass, their fuels are different. I mean, everything about them is so different that you really have to drill down a bit to make apt comparisons beyond just the numbers. And John does that wonderfully in this article. So again, that's on the nss.org website. Just click on the free Moon Rockets article button, and all we ask for is your email address so we can bug you about joining the organization. But you can always, you can put it in one of your disposable emails and not worry about it. All right. So as you put it so aptly, Tariq, first there was the mighty Saturn V, then the Soviet N1, hardy har, and now we have three new contenders for the most, quote, ginormous rocket, unquote. And I didn't realize that ginormous had become a term in art and journalism, but there we go.
It is in the dictionary, Rod. It is in the dictionary. People can look it up.
Probably you probably use Webster, right?
Yes, I do.
Okay, it ain't in Oxford yet, I don't think. So we, we're at this crux, this moment in history where we're going back to the moon, which is great. It's welcome. One thing we're not going to talk about today, but will in the future, is the rocket the Chinese are building to try and accomplish the same thing and a little further out. Mm-hmm. But right now, it's a U.S. game primarily. And we got these two big rockets staring at each other, the Space Launch System and Starship. And everybody that listens to the show has heard us talk about the Space Launch System. It's a big, conventional, traditionally contracted, lots of money spent for something that you launch once and throw away. I will point out, we'll be talking about costs and so forth as we go on. It's as expensive as it is, and at this conference for the last 3 days, I've been hearing a lot of belly aching about the SLS because there's a lot of people in the trade that aren't fans. I would like to point out it's still, at least at this point, projected to come in at under half the cost of Saturn V. So it's not like the Saturn V was such a bargain. I mean, that was a big, expensive program, the biggest thing done in peacetime by anybody ever. And we spent a lot of money doing that. That said, when you look at this as we're just using shuttle technology, but trying to basically recreate the Saturn V with all that knowledge we earned 50, 60 years ago, by golly, it seems rather expensive. And then you get into talking about cost plus contracts and the way the government used to operate, hopefully won't in the future, at least according to Bill Nelson. And that conversation gets a little uglier. But why don't you kick us off with your assessment of what's going on and what's important about it?
Well, just for background. So we had these two giant moon rockets, we're going to call them, the Saturn V, which, the NASA launched, I think, 13 of them. And in the 60s and the 70s, they were successful, and they launched people to the moon. Of course, they started launching in 1967. That's when the first test flight of the full rocket flew. And then, of course, the Soviet Union countered that with the N1 rocket. They tried to launch it 4 times. It was huge, but it was never successful. So I wanted just to put that on the board, because when people think about giant rockets, they think about the Saturn V first. And now we've got these new ones here. Now, the Space Launch System is a rocket.
Can I jump in for 1 second?
Yeah.
Real quick. Sorry to interrupt, because you were right in the groove, but the N1 is an interesting thing to look at if you've never spent much time looking at it, because it's about the size and lifting capacity of Saturn V, but it had, I believe, 32 engines. So it was much like Starship. it had this huge cluster of smaller engines because the Soviets hadn't mastered the huge single chamber engines like we did for the Saturn V, which had
Yes.
5 enormous fuel gulping engines at the bottom. So they had this huge, these concentric rings of smaller engines, but this being the 60s and the Soviets just barely being off of vacuum tubes at that point in terms of computing and so forth, they were apparently, from what we've been able to see since the fall of the Soviet Union, the big problem was the engines tended to start running out of sync because the computer control was so rudimentary. They just couldn't do it. Presumably, SpaceX will not have that problem with Starship. But I tell you, man, you look at the bottom of the N1 and you look at the bottom of the Starship first stage, and you think, golly, those things look a little similar.
Yeah. The N1, according to the graphics that we've built over time, had about 30 of these NK-15 rocket engines, a big giant ring like you mentioned around, and there's a smaller ring on the inside, and then it had an upper like a next stage with 8 engines, and then another one with 4, and then you started getting up in the 4th and 5th stages that had single engines before you would get to the 7K L3 LOK lock spacecraft on top that would go.
Wow, look at you!
Take the cosmonauts to the moon.
You're good with that.
So that's compared to the 4 stages of the Saturn V. It had 3 stages, and then of course the Apollo spacecraft and the module on top. So. But you're right. SpaceX. We're going to talk about Starship and their clustered engines in a bit too, because they're taking a stepping stone approach. They're not going to test them all at the same time. They started with 1. They started scaled to 3, then 5, and they're getting up there now. But yeah, so kind of the initial era. This started back in 2004. NASA decided it needed a new mega rocket to go back to the moon, and the Ares 5 was a progenitor of that, and later that evolved into what we have now, the Space Launch System, that has, as you mentioned, a lot of legacy hardware in it. It uses 4 RS-25 engines. Those are the main engines used on the space shuttle to power its first stage. It has a giant tank that looks like the space shuttle tank. It's just a lot bigger. That has the liquid hydrogen, liquid oxygen, again, because that's what the engines are designed to run on as propellant. And then it has the 2 side boosters that are basically a larger version of the space shuttle SRBs, and those are built by Northrop Grumman. And you put it together, it's a lot of really familiar hardware, which of course allows NASA to preserve as much of their work base that they could. But it was required, it's written into law, that they had to build the rocket this way by the Senate. It used to be nicknamed the Senate Launch System for a while.
What do you mean used to be? So this was in 2004. This is baseline for the Constellation program under George W. Bush, right?
Well, in 2004, the Constellation program, the Ares 5 rocket was the heavy lift, and it was a bit different.
Right.
It did not look like this. It was a giant rocket. They had split a lot of the payload for crew and cargo between a smaller rocket called Ares 1, which, if you imagine a solid rocket booster from SLS and just put a crew capsule on top of it, that's what it was. It had like a big fat upper stage. It looked like a corn dog. If you were holding
with a really stubby dog, yeah,
right. You I'm not kidding. People should look it up. Look up Ares 1X. You'll see what I'm talking about. It looks like a corn dog. And so that was the plan then. But SLS combines the crew launching capability, and you could swap it out for payload going forward. Now NASA wants to build different versions of this. The one that we have now is the Block 1 rocket, and it's designed to launch 56,000 pounds of payload, off to deep space. And it has a lift capacity of 8.8 million pounds of thrust. That's more, it's about 2 million more than the Saturn V, which makes this NASA's most powerful rocket, right? And so they're really trumpeting.
When it's leaving the ground, it's the most powerful.
When it's leaving the ground, yes.
But less capable than the Saturn V. Yeah, okay, we'll get to that.
I mean, there is a payload, and the current one uses an upper stage called the am I going to get this wrong? It's basically the temporary,
the interim upper stage, the IUS.
Interim cryogenic propulsion stage, and that's meant to just basically get Orion, the crew capsule, into space. If they want to launch really big things, they need a bigger upper stage. Boeing is building it. They don't have it done yet, and they want an even more powerful one after that power what they call the Block 2. And, we're really, I don't think we should be talking about that now because we should probably get this first one off the ground. But that's the main thing. Now, NASA had hoped to be able to use this rocket for a lot of different things to launch hardware to the moon, things like habitats, pieces of the new Gateway station. Maybe it'll launch interplanetary missions like the Europa Clipper to Jupiter. But it's been delayed so long. The first flight for the SLS was supposed to be in 2017. So it's 5 years late. It's really expensive. And NASA thinks that once they get up and running, and by up and running, I mean like having a reliable rocket after Artemis 3, which is the moon landing in 2025, they want to launch one a year. So that's one flight a year going forward, either to the moon or somewhere else. So that's kind of where we are right now. NASA just has not been able to get it off the ground, and they've been trying for the last 6 months when they rolled it out for the first time in April of 2022. It is a very proven rocket, at least on paper, with the hardware that they're using.
Well, the components are. Yeah.
The components, yeah, but we haven't seen them all work together yet, and they've tested as much as they can separately. But as we've been talking about, and update after update, they just have been having a lot of problems. So that's kind of where SLS is, and the reason that I want to say that is because while we've been waiting for SLS to fly, we've seen the rise of these other rockets.
And waiting. Sorry.
And that's, I know we're going to talk about Starship, but SpaceX built and has launched the Falcon Heavy in the same time that NASA has been developing the SLS. The Falcon Heavy rocket is currently the most powerful rocket in use today. And so much so that NASA has reassigned the Europa Clipper mission, a mission originally assigned to SLS, to the Falcon Heavy, because SpaceX has Falcon Heavy rockets and has launched them. I believe they just recently launched the third one, the fourth one, just recently in the last few weeks. So we've got this other rocket that's available now, and the big question is really, do we need the SLS? We're going to talk about that, I know, but that gets us teed up for Falcon Heavy and SpaceX. Right now, you want to take that one away, or you want to talk about SLS?
Well, there's some. I have some interim upper stage comments, but before I get to those, you hang around space conferences and you hear a lot of engineers, a lot of former NASA people, some current NASA people, quietly, who shall remain unattributed, kind of saying, we know Starship is a ways off. We're not sure what the capabilities will be. However, we do know that Falcon Heavy works. The prices range from 80 million to a couple $100 million to launch. A couple $100 million is only if you're getting into these complicated military launches that need a lot of ground support, but on average about $100 million, which is a lot less than the $4.1 billion that SLS will cost. And the Falcon Heavy, depending on what grid you're looking at, is anywhere between maybe 60 and 70% of the launch capacity. So if I think I have that number right. So you can buy a whole bunch of them for the cost of one SLS rocket. They work. They're very reliable. It's not just scaled up Falcon 9s cobbled together. It was a lot more work than that, as it turned out, contrary to what Elon thought initially, but it works. And so there is a lot of conversation around, because back even in the days of Apollo and when the Soviets were looking at the getting the moon problem, there were a lot of conversations about multiple launches that would string together spacecraft either in Earth orbit or lunar orbit and carry it off that way, instead of having to have these mammoth space moon rockets that we had built. Ultimately, that was deemed the safest configuration, but we're a lot better at finding other spacecraft in Earth and lunar orbit than we were then. And that's something you could do. So there are a lot of questions circling around. Can't we just use the Falcon Heavy and get on with this? And the answer from NASA so far has been, no, we don't want to do it that way. But it is an interesting conversation. Before we go to the break, I would just like to, if you're down for this, read off some numbers to kind of kick off this discussion, so we've got some context. Sure. And it's hard to wrap your head around these because they're large. And it's hard to give context. And when you're trying to compare these things, you have to keep the units the same. You have to remember that some of the payload measurements are at low Earth orbit, whereas others are out to lunar distance and so forth. So there's a little bit of variability, but in very broad terms, SLS versus Starship. So for payload for the SLS Block 1, it's about 60,000 pounds, which is less than the Saturn V. Block 2 is about 84,000, Block 1B is about 84,000 pounds, and Block 2 is about 95,000 pounds. So somewhere between those second two iterations, you get up to Saturn V class. So it's really interesting that the SLS has more takeoff thrust, more liftoff thrust than Saturn V, but because of that wimpy upper stage, which only has one 25,000-pound rocket engine, which isn't a whole lot more than the original X-15, you can't deliver. You don't have that much kick to get heavy objects out to the moon. Starship.
Do you know what the secret? Do you know what the secret to that liftoff thrust is?
It's those big SRBs.
No, it's the 2.5 segment SRBs that add 70% of the thrust at takeoff at liftoff is from the SRBs themselves.
Yeah, I think they're 3.5 million pounds each or something. So it's like crazy. You light the skyrocket and that sucker goes up whether the liquid engines light off or not.
The people behind those SRBs are really proud of him. I spoke to the program manager at the first launch attempt, and they are really just proud. Well,
they should be. Boosters. And the only bad thing about them is they don't throttle and you can't shut them down.
And you don't get these ones back. They will not be reusing them.
No, that's nothing. And I'll get to that. So hush. Starship.
sorry.
With proper refueling, and that's a big question. How many other flights do you need of other Starships to refuel? But with proper refueling, maximum weight deliverable to lunar distance is over 200,000 pounds. So that's a big win. But probably still for less money than a single SLS launch. The thrust of SLS at liftoff is just under 9 million pounds. As we said, solids are about 3.6 million each. Thrust of Starship is 17 million pounds, so it's a gorilla. Cost of SLS is about 4.1 billion this week. Cost of Starship, well, by golly, that's a little more difficult to tease out. Elon says, well, it could get down to 2 million. Before that, it'll get down to 10 million. It might be 100 million, or it might be more than that. I'm just not sure. But those are all way smaller than 4 billion. So it looks like it'll be a winner there. On SLS side, the only part that's reusable possibly is the Orion capsule. We don't know how many times because we haven't tried yet. Starship is all reusable in theory. We'll see, including the engines, which are made to sort of be dusted off, washed out, and used again within the same day, possibly at some point. Let's see. Oh, finally, environmental impact. On SLS, the core stage is fairly green because it's hydrogen and liquid oxygen, so the resulting exhaust is water. But the solids are very dirty because of the chemicals in those. Starship is slightly dirtier. Yeah. Fertilizer, basically. Starship is dirtier because it's using methane instead of hydrogen, but that said, probably the net effect is less than what you are getting from the solids on Starship. So that's kind of the grid in a nutshell. SLS is more powerful than Saturn V in the first stage, but weaker because of the upper stage until we get to more advanced upper stages. That RL-10 engine that will power that interim upper stage was first flown in 1962, so it's not new. It's an expensive thing to manufacture. So like the four engines that power the liquid fuel engines that power the SLS, these are kind of the Ferraris of rocket engines, and it's an expensive way to do business when you're throwing them away, and so on and so forth. So I'll leave that right there. We do have to go to another break, and we will be back in just a few minutes with the good stuff. So that was kind of complicated and probably sort of causing some mental pain for some people because it's never fun to listen to a bunch of numbers right off on the air. But I just thought it was important to get some of these numbers down because it does help frame the discussion. Although, as I was saying earlier, and you alluded to, that's not the whole story, right? There's more going on here when you're trying to sort of tease out how you want to get to the moon. And this, again, doesn't touch on the rocket. The Indians are developing bigger rockets. We don't really know what the Russians are up to because they keep saying they're going to do X, Y, and Z, but they don't have much money to do it. So what's your view since you're in that high altitude ejection seat and you see all this news from minute to minute, what's the latest on how you think this is going to play out? And let's not forget that even NASA's plan for getting the moon is we put 3 astronauts on the SLS and a little tiny capsule up top, which has about I think 400 cubic feet of pressurized environment. And we send those astronauts off moonward. It rendezvous with the SpaceX Lunar lander, which is a Starship that's been modified to land on the moon. And two of those astronauts climb up in the nose of the lunar lander, which has more internal volume than the ISS at about 36,000 cubic feet. So it's, two guys sitting on top of this enormous cavernous semi truck behind them. They land tail first on the moon and come home. So it's already a hybrid system.
Yeah, it's interesting because I think that really puts the situation that we're in now in really clear perspective. Because before, like it was very simple, right? Each country has their giant rocket, the Saturn V and the N1, and they're going to try to go to the moon. NASA did it. Russia did not. And then you see these private companies that have their own business cases to go to the moon. Elon Musk wants to send people to Mars. He has said that many, many times. And to do that, you need a great big rocket. Now, initially, SpaceX had said that the Falcon Heavy was that rocket. And the Falcon Heavy is a rocket that debuted in a few years ago, and has it made its first flight this year. Since I think the last one that they had launched was in 2019, and that's a vehicle that is 3 Falcon 9 stages. Essentially, it was a vision to be just 3 first stages put together with another one on top in the center. SpaceX ended up having to make a bespoke central core stage that's a little bit larger than the Falcon 9 to do it. But that was supposed to be their giant rocket, and it can carry up to 37,000 pounds of payload to Mars. It's mostly reusable, with the 3 first stage boosters coming back to Earth. SpaceX has had a hit or miss record of sometimes planned of getting all 3 of them back. The core stage they've thrown that away a couple times for mission design, but it can carry these massive amounts of payloads. But it's limited by its fairing size, and that's one thing that NASA says that is a bonus for SLS, is that it can carry the large payloads and fit them in a giant fairing. And we're going to talk about why that's important in a bit, because our rival to SpaceX, Blue Origin, is building their own big rocket that is also reusable, that has the world's largest payload fairing on it too.
Which we've also been waiting patiently for, and waiting and waiting and waiting.
That's right. But so that's the game, is that if you're going to kind of stack up where anyone is in the giant rocket game, SpaceX is clearly ahead. And that's because they have the most powerful rocket in use today, the Falcon Heavy. They've flown it multiple times, and they've got plans to fly it again. And originally, this was a rocket that SpaceX had wanted to use to send a Dragon to the moon. They might still do that. We don't know. But it's a 230-foot tall rocket. It's like 40 feet wide in terms of like the diameter, and it's proven now. It uses the technology SpaceX has iterated over years to launch rockets into space to bring the first stages back. Part of it aren't reusable. The upper stage in particular is not, but the fairings are. They've flown them multiple times on different Falcon Heavies, and so that was the origin of all of this. Now, while SpaceX was getting Falcon Heavy ready and they launched the first one, that's when Elon Musk announced in I guess it was 2016 was the original time, as they were getting the Falcon Heavy ready. But that was the first time he unveiled like this plan for what was the BFR, which I'm not going to say what that stands for, or the
big Falcon rocket. Everybody knows that.
That's right. Falcon is what the F stands for. Correct. To go to Mars. And he has since said that that's going to be their big workhorse workout. And Starship, to put into perspective with what we're talking about, is 395 feet tall. So about 30 feet taller than a Saturn V. They've stacked it on top. It's 2 stages, fully reusable design, and it will carry this, what they call the super heavy first stage, this massive stage that is powered by, I think it was 30 rocket engines, the Raptor engines. I'll have to go
in
back
theory up to 33, but I think
up to 33. That's right.
Practice,
and the Starship itself sits on top. It's the same width, and it's powered by 6 of its own Raptor engines, and so SpaceX has been slowly testing. They've launched Starships, different versions of it, to a suborbital altitude, so about 12 miles or so, and they finally like stuck a landing last year, and then they've been scaling up the super heavy. And first they did 1 engine, then they did 3, then they did 5. So they're slowly adding the complexity in a way that we've seen SpaceX do over time, and so it seems like they are way ahead of NASA even with this this capability of a rocket. NASA's ready to launch their first uncrewed test. SpaceX has not only developed suborbital versions of their rocket. Now they haven't built one for orbit. That's planned for this year. We'll see if that happens. But they've already signed a contract to deliver astronauts to the moon using Starship, which will require not 1 or 2 or 3 Starships to do. It's going to take something like 8 to 16 Starship launches to get astronauts to the moon with this lander, because they have to launch a Starship into orbit. They have to launch another one to start refueling that Starship. And then they have to just keep doing that until they give it the amount of propellant it needs to get to the moon, where it will then rendezvous with an Orion and get people down to the surface. So that's the plan right now.
However, there's a question as to how many they'll actually need to do that, because first of all, on the one side, they haven't tested this recovery catch system, the so-called chopsticks that are on the launch tower that's supposed to catch the rocket coming home. But if that works, and if that works reliably, because they don't have as much fuel boil off as a liquid hydrogen fueled rocket does, I suppose in theory, if they can really turn this thing as quick as they say, maybe if they have 4 Starships, they can cycle them through to do this multiple refueling. But it's a big, complicated
it's
assembly
very
line
interesting.
they got to do to make it work.
And again, so NASA is ready to launch this first orbital, this first, not just orbital, but this first moonshot test of SLS. And if everything goes right, it will launch before the end of 2022. The same is true for SpaceX's Starship, because they have built an uncrewed version of it in Boca Chica, Texas, at the very, very southern tip of Texas, where SpaceX has a Starbase facility. And they are planning right now to launch the first Super Heavy and Starship, that 400-foot rocket nearly, into orbit, and then just dump them both offshore. The Starship will splash off the coast of Hawaii, and then they'll be able to get running there. Now, SpaceX has already sold 2 flights to the moon with passengers with Starship, and that will help them fund all of this. And of course, they've got the NASA contract to land not once but twice, a test flight and the crewed flight for Artemis 3 right now. So it's they've in terms of hardware, NASA's got this big rocket on the pad. I think SpaceX is really making headway. It's, to me, a toss-up which one might be able to carry people first. So.
Yeah, and then there's that other conversation about here's the guy, Mr. Musk, who has revolutionized launch and space flight, you could say, but really the world launch industry. And SpaceX is not shareholder owned like say Boeing or Lockheed Martin is, which I think helps in terms of their agility and their being able to pivot quickly. And yet here he is, tied up with Twitter, and I know that's talked a lot about on the TWiT network. So distracted and so apparently overwhelmed by that, and you just kind of wish he'd stick with the original plan. But let me revise some of my numbers. So I had not scrolled down to them when I was voicing them in my memory. Starship is 39,000 cubic feet, or 1,100 cubic meters of pressurized cabin space. Orion is about 600 cubic feet, so a little bigger than I quoted, about another third or 40% larger than Apollo, or 20 cubic meters. ISS is 33,000 cubic feet, or 916 cubic meters. So it's amazing to think that we'll be launching something larger than the space station possibly as often as a couple times a week. Which is,
and you mentioned the way that SpaceX wants to recover these, and we should just I want to really briefly make sure that we touch on a couple of other rockets that are really big and coming down the pipeline. But SpaceX's plan, and they're building 2 launch sites. They've got one in Boca Chica, Texas, for tests, and they are also building next to their Kennedy Space Center launch pad at Pad 39A, another giant tower to hold again the the 395 foot tall Starship, and they have this thing called, I think it's Mechzilla is what they're calling it.
Yes.
It's the tower that sits next to Starship, and it has these two arms, these robotic arms that pinch. They close together like chopsticks, and SpaceX uses that to hoist, the super heavy rocket booster onto its launch stand, the Starship itself vehicle on top of super heavy, and they want to try to catch the super heavy booster on these chopsticks when it lands, so that they can then put it back on the launch stand and then just gas it up and get ready to go again. It's really novel. It's very daring, which SpaceX is known for.
Absolutely.
But will it work? That's the question that you just mentioned, because if it doesn't work, it means they're going to have a really hard time trying to either move the rockets back and forth. That could add downtime to the whole plan that you were referencing earlier. So
yeah, and I don't think there's
another.
I don't think there's another landing option either. I'm not sure they're going to be having the little stubby landing legs on the future version. Certainly not for the first stage. So they kind of need that to work. Again, you go to space conferences and you hear a lot of people who are more in the know than I am talking about how is this going to play out. So there's a lot of talk about, SLS will get canceled before it gets launched. Well, I doubt that, because we're way committed into it money wise. There's a lot of sunk costs into Boeing at this point to make it work. There's laws written, as you'd pointed out, that mandate basically if you're going to go to the moon, you have to use it.
They've got hardware for at least 5 rockets that underway right now. They've got plans for at least through Artemis 9, Artemis 10. So that's water under the bridge on whether or not we're going to use it. This is the rocket we have right now at NASA.
Right, and that's a really good point. This is the moon rocket we've got. Starship is the moon rocket we hope to have soon. Falcon Heavy is the moon-capable rocket that we're not using for that. So SLS seems to be the one to beat. Now, this test flight has to go well. If there are serious problems with it, they'll either get fixed or potentially could stop the program if Congress got sufficiently angry at what's going on. And this is just, I'm just guessing here. This is not the official viewpoint of the National Space Society or space.com or anything else. This is just us chit-chatting about it. It could get canceled, or they could fly out 4 flights, do most of the Artemis goals, and decide, okay, that's enough. This is expensive. Elon's flying this really affordable, bigger rocket. Let's use that. Or they could stick with SLS for 20 years or more, like I did with the shuttle. That's a little hard to fathom, but it's possible.
I asked Bill Nelson, the chief of NASA, that exact question. If it fails, what happens next? And that's what he said. They're committed. They will make it work, because they've got the hardware built already. As we're talking about, SpaceX versus NASA, SLS versus Starship, we should point out that Blue Origin is building New Glenn, a giant rocket.
Who's that?
Blue.
Oh, that
Blue
Bezos
Origin. Guy.
Yeah,
Jeff Bezos is Blue Origin, and it's another massive mega rocket. Again, it's not as capable as Starship, but it is huge, and it has the biggest fairing that is planned for right now. Starship would have to have a hatch to open up to let payloads like a space telescope go out, and they've got plans for that. Don't get me wrong. But Blue Origin has been making some progress. Now, they've been slowed, of course, by the development of their BE-4 engine, but their rocket, the New Glenn, named after, of course, John Glenn, is slated possibly to debut, next year, and they've got plans for 45 tons to low Earth orbit, 13 metric tons. It will be taller than the Falcon Heavy, but not as tall as the Saturn V, about just between 90 and 100 meters, and it will land the first stage offshore, just like SpaceX plans to use and does with their Falcon and Starship stages, and of course, but it will be fully reusable. The second stage will come back to be used again, and so that is rising in the back. They've got this 7-meter fairing, which is more than twice the volume of any other 5-meter class that's in use right now, including the Falcon Heavy. And so that's kind of their big play. Now, it does rely on Blue Origin's engines being successful. They haven't tested it yet. They haven't even built one yet. Although I have seen the giant facility that they've got at Kennedy Space Center. that they're building their rockets in. And then meanwhile, behind them is the United Launch Alliance, which is phasing out their previous most powerful rocket, the Delta IV Heavy, which used to be the world-class rocket until the Falcon Heavy came along. And they are going to be replacing that in 2024 with the Vulcan rocket, which is not as reusable. I don't think there's very much reusable on it at all, if memory serves. And
they're supposed to catch the engine pod.
The engines, the BE4 engines, they want, because they're the most expensive part. And this is a rocket that will be scalable from like a medium to heavy lift version to a heavy lift version using strap-on solid boosters, so they can launch
lots of them.
Lots of them. It can launch by itself. It can launch with 2. It can launch with 4, and it can launch with 6. That's the heavy version. That's also been, we're expecting the first flight of both that and the Blue Origin New Glenn sometime in 2023. Again, they're phasing out the Delta IV Heavy by 2024, and then that'll be their go-to. So some synergy there because it uses BE4 engines as well. So they're collaborating in a bit with Blue Origin.
Co-opetition, as we like to call it.
So they're not as those two rockets right now. They're not at the scale that SLS and Starship are, and so there's been a lot of back and forth, particularly between Jeff Bezos and Elon Musk and Blue Origin and SpaceX over their respective vehicles, because Blue Origin was at one point and still is again a contender for crewed moon landers for NASA. SpaceX won out the first contract. A lot of bad blood between the two groups over that. So.
Well, it should be mentioned, we do some head scratching and occasional finger poking about Blue Origin and their lack of progress on the large rocket side. To be fair, and you've seen it, I haven't, but I've heard a lot of people talk who have been through the new facilities at Kennedy and the facilities in Washington State and the facilities in Texas and Huntsville too, I think, right? Blue Origin?
Yeah, they've got stuff kind of spread out around.
These are big rocket plants. These rival what Elon has in Hawthorne and more. So they're clearly committed. It's not moving as quickly as a lot of people would like. And there was an article, I think you put it out about a year and a half ago, with some complaints about the work culture at Blue Origin. But the same has been said about SpaceX. And if you hang around NASA long enough, you hear the same complaints there in a slightly different vein. So it's the nature of the business, and it's a growing industry, and it's new for private companies to be doing what they're doing the way that the Blue Origin and SpaceX are doing it. So it's not surprising they'd have some growth pains.
And I would caution everyone about counting out, a company like Blue Origin, because for years you didn't hear anything at all. And then they launched their first suborbital test flight and landed that rocket, and it amazed everyone. No one saw it coming off that spectacularly. And so it's quite possible that when they've got something to show, they will have something to show, and it won't be it'll be something like a full up rocket that will just come out and they'll do the test and everything. So we'll see. But again, they are behind schedule, and a lot of it's because of the engines. So. But it's in a time where we were used to having one giant rocket. Now we've got at least 2, maybe 3 or 4 that are coming down. And that's just, we didn't talk about the Ariane 6, which is going to be a new heavy lift dependence for that Europe is planning. You mentioned China. They have a kind of a Starship-esque plan as well.
What do you mean esque? It looks exactly like Starship. One would almost think they had possibly, seen the plans for Starship or something.
Well. So I can't speak to that, but we're much like where we are now with the rise of private rockets. You've got Blue Origin, you've got Virgin Galactic, you've got SpaceX and Rocket Lab, etc., where we have many different kind of private space programs. I think we're going to see the same for giant rocket programs. SpaceX already has passengers signed up to fly on their rockets. They've already flown passengers, not just to orbit, but to the space station as well. And they've got tickets sold to the moon. So it definitely is a new era. I get excited because I'm the rocket guy, and I really, really love seeing this stuff. I hope it all succeeds, because the more, the merrier, and we get closer to that sci-fi future.
Well, I'm glad you get excited. I come from a world where I remember these incredible missions of exploration thundering off to the moon as often as every 10 weeks. It's been hard to stay patient for the return of something like that for 50 years, but I'm trying, And when our first crewed landing does happen on the moon, hopefully in a handful of years, you and I will be virtually toasting with scotch. Well, you'll probably be at the launch, but we'll have a
You should
toast
come.
afterwards.
We'll have a party.
I'll be at home. Well, I might. We'll see if I can get some travel funds put together. Clearly, there's a lot more to be covered here, and I think we'll have more to say after the launch. And we have some guests coming up that are going to have some expert observations about that first Artemis mission. But before we go, give us a capsule summary of why the heck Amazon is going up on Artemis 1 and what it's supposed to do. Because the one thing I want to make sure is that so this is being mounted, as I recall, the actual pickups will be or micro speakers, excuse me, will be mounted in the dummies. And there's a skeleton interface on the spacecraft. The commands that you probably don't want to use are things like eject, abort, re-enter, fire, or self-destruct. But other than that, if you want to say, hey, how much fuel do we have? Or what time is it? Or what's our altitude? What's our perigee? That's probably okay.
Yeah. This is an interesting experiment. I spoke with some of the designers from this at the National Space Symposium earlier this year, and they gave me a run through. And the goal is to really streamline the abilities of astronauts who they're very busy people, especially when you're going to the moon. And there's a lot of stuff on a spacecraft that you have to check. Like what is the oxygen ratio in the air? What is the carbon dioxide scrubbers capacity right now? That sort of thing that Houston needs astronauts to check just to make sure that everything is healthy, as well as ways to get messages to the crew in an easily accessed a format. And so they're going to test using voice commands for this to check systems. What's the temperature right now? What's the airflow, etc. That sort of thing, to see if it can make astronauts' lives a little better. One thing that's really interesting is in mission control, they'll have a console, and people can use like a light pen to write on it, and they can write messages that will then appear in near real time. Of course, there's always that light delay as the spacecraft gets further from Earth, but it will appear on the screen on the Orion, inside the Orion capsule. So that would allow people to send quick notes. Hey, can you go check this out? Or this is what it looks like. Or no, here's the number of that this sensor reading is. And they're like, all right, okay, great. So it'll save them a lot of time. And now this is just mounted right now on the Orion hardware, but you can envision a system like this that an astronaut might have on like a pad or whatever as they walk around their gateway space station or their moon base or whatever, and they can communicate near instantly with folks on the ground or get information a lot faster instead of having to go to a computer, go look at a bunch of switches or dials and try to find it. They can just ask the computer to tell them. So, we have smart homes right now on Earth with our Ring doorbell, our Nest system to adjust all the cabin stuff. This is kind of the precursor to something like that for a moon base, for a moon ship, for astronauts in space.
You just called your home thermostat adjustments for cabin pressure. Geek. All right. Well, we have to go, but this has been fun. I look forward to doing it again. I want to thank everybody for joining us today, and be sure to keep your eyes on the upcoming launch attempt for Artemis 1 on November soon. We'll be back with more news about that with assistance from an astronaut, NASA tells us, in a couple of weeks. Tariq, where can people track your personal launch status?
Well, they can find me on Twitter at Tariq J Malik, where I have the blue check for now, but we'll see. and at
are you prepared to pay is the question.
No comment. But they can find me at space.com as always, where hopefully we'll have all the news that's fit from space and bring it down to you daily. So. And
you can always find me at pylebooks.com or at astromagazine.com or my home organization for the magazine, nss.com. I'm also on Facebook, Twitter, and occasionally Instagram. Please don't forget to drop us a line with a joke if you're brave enough at twit.tv. That's TWIS at twit.tv. We welcome your comments, suggestions, and ideas, and that's why we have email. So send it in. And don't forget, new episodes of this podcast published every Friday on your favorite podcatcher, so make sure to subscribe and tell your friends. And give us a review, because I think we've earned it. And I want to mention that you shouldn't forget that you can get all the great programming on the TWiT network ad-free on Club TWiT, as well as some extras that are only available there for $7 per month, which is probably going to end up being cheaper than Twitter in a few weeks. So it's a good deal and undoubtedly much more entertaining. Finally, you can follow the TWiT Tech Podcast Network at TWiT on Twitter and on Facebook and twit.tv on Instagram. Do it all because we're that interesting, and we will see you next week.
Is that an iPhone in your hand? Wait a second. Is that an Apple Watch on your wrist? And do I see an iPad sitting there on the table? Oh my goodness. You are the perfect person to be watching iOS Today, the show where Rosemary Orchard and I, Micah Sargent, talk all things iOS, tvOS, watchOS, HomePod OS. It's all the OSs that Apple has on offer, and we show you how to make the most of those gadgets. Just head to twit.tv/iOS to check it out.